Okay, so again, like I said, we're going back to definitions we kind of have already heard. So the first definition we have is a relation. A relation in its most basic definition is simply a set of ordered pairs. A relation is a set of ordered pairs. An example would be the subset 2, 3, 1, 8, 0, 7, and negative 1, 4. So an example of a relation is 2, 3, 1, 8, 0, 7, and 1, negative 4. Now we can define a relation as either discrete or continuous. So relations can actually be classified again. But before we do that classification, we're going to talk about what the two mean. So a discrete relation is a relation in which the domain is simply a set of individual points. So the domain acts as a set of individual points. The graph from the warm-up would be an example of a discrete relation. So the graph in the warm-up would be an example of a discrete relation. It is a relation in which the domain is a set of individual points. So if you look at, again, the warm-up, what I mean by that is that in 1 through 5, these are simply a set of individual points. They have no fluidity, they have no flow. I can't really connect them to get a graph. So this warm-up here, 1 through 5, those points are a discrete relation. A continuous relation is when the domain of a relation has an infinite number of elements and the relation can be graphed with a line or a smooth curve. So a continuous relation is when we graph our points and they appear to connect nicely, turning my points into a function. We already know this, but by definition, the domain is the set of x coordinates. We also refer to domain as inputs. So you may also hear the domain referred to as the inputs. So some of the terminology that is changing. The domain is the set of x coordinates or the inputs. The range is the set of y coordinates or the outputs. If you look, the example above is in purple and white. The example for domain and range is in purple and white. The reason for that is because this example of the domain comes from that relation. This example for the range comes from that relation. So the range of the given relation was 3, 4, 7, 8. That's what I have down here is the example. So again, when I'm giving you those examples, they actually have purpose and value. They match the two definitions. What we're going to do today is solely focus on graphing points, describing the graphs of those points as discrete and continuous, and identifying their domain and ranges. Okay, so example 1 and 2 in the back, they've listed a set of relation points for you, and what we're going to do is plot out those points. So in number 1, we have 0, 4, so x comma y, x is on the horizontal, so the horizontal 0 is at the middle, and we go up 4 coordinate points. Negative 2 is to the left 2 of the horizontal line, and then up 3, negative 1, 3, so you go to the left 1 and up 3, negative 2, 2, so we go left 2, up 2, and 1, negative 3, so we go right 1 and down 3. Again, when I'm saying those, I'm not listing them as slopes, that's different. These are just coordinate points. So looking at these points, would you say this is discrete or continuous? So that's the first thing we want to talk about. Is that discrete or continuous? Well, continuous is forming a smooth line or curve. These are not really going to form a smooth line or curve. So this is a discrete relation. Is this relation, and I know we didn't talk about the definition yet, but is this a function? Yes or no? Thumbs up for yes, thumbs down for no. Let me see what we think. So yes or no. Okay, so no, some yeses. What do you think? Some in-betweens. Okay, so good. A majority of us are putting up no. This is not a function because right here it fails the vertical line test. Or the idea is that negative 2 repeats on x and a function cannot have repeating x's. So this is not a function. The reason I'm adding that in today is because some of those popped up on the homework on us and I didn't have it as a definition. Okay, so remember domain are your x's. So my x's are the first coordinates, so it's negative 2, negative 1, 0, and 1. Remember, you have to have them in bracket or set notation. The range are the y's, so we have negative 3, 2, 3, and 4. Graphing the next set of points, we have negative 2, 1, so left 2, up 1, negative 1, 0, so we just go left 1, stay on 0, 0, 1, so we go from 0 and up 1, and then 1, 2, so we'll go to 1 and up 2. Now, would you describe this as discrete or continuous? Could I easily connect these points? Probably, because it looks like it goes down, then it changes direction, and it goes back up and appears to be continuing in a nice line. So I would look at this and say that it is continuous. Is this a function? Do any of my x values repeat? No, so it's a function. And let's talk about the domain. Well, the x's appear to be negative 2, negative 1, 0, 1. And the y values, which again, y can repeat, are 0, 1, and 2. But even though it repeats on the graph, we do not repeat it when we put it in our range down here. So if you had 1 repeated, erase that second 1. You cannot repeat range values. So when you write your domain and ranges, you cannot repeat the values in the set notation. When you write your domain and ranges, you cannot repeat the values in the set notation. Okay, take a minute, look at examples 3 and 4, and go ahead and list those coordinate points for me. So take a minute and list the coordinate points of example 3 and 4. So when I ask you to list the coordinate points, I'm asking you to give me the relation like we were given in example 1. So I almost want you to do the reverse of what we were given in 1 and 2. I want to know, okay, what does this look like as a set of ordered pairs? Then let's describe it. Is 3 discrete or continuous? Well, when I look at that, it's going to be discrete once again, because I cannot really connect those points in a nice fluid pattern. This one, however, would be a function because none of my x's repeat. Your domain are those x values, so you have -4, -3, -2, 2, and 3. I'm going to have fewer range values than domain values because once again 4 repeats in my range. So I don't repeat it when I write it in my set notation. Okay? Example 4. Once again, your relation points would be -3, 2. 0, 2, 3, 4, and 4, -3. Oops, sorry, 0, 1. Thank you. Your domain is going to be -3, 0, 2, 4. And your range is going to be -3, 1, 2, 4. Looking at this one, even still, I can't really connect those points, so we would identify it as discrete. Okay, 5, 6, and 7 are to make a mapping. So again, you kind of have to think back to chapter 0. What was a mapping? Well, a mapping was when we had the domains and ranges listed in their own bubbles, and we drew the lines connecting them. So in 5, you list out your domain. So you have -1, you have 7, and 3 and 7 are going to be in my range. So again, My domain and range are relatively small. They each only contain 2 values. We have -1 mapping to 7, 1 mapping to 3, but then we get 1 also maps to 7, and -1 also maps to 3. This would fail the vertical line test because the values of x repeat, so this is not a function. It would also be a discrete relation because those 4 points aren't really going to give you anything smooth. For mappings, you don't have to list the domain and range because that's what you're doing in those individual bubbles. You're telling me, okay, I know the first bubble's the domain, and I know the second bubble's the range. So here, domain is 0, 1, 2, range is 2, 3, 4, 0 maps to 2, 1 maps to 3, 2 maps to 4. This is a function, and because they go up in a nice even pattern, 0 to 2, 1 to 3. So this goes up by 1, this goes up by 1, this goes up by 1, this goes up by 1. On a graph, this would be continuous. Okay, in 7, we have the 2 maps to 8, -1 maps to 5, 0 maps to 8. So right now, this would still be a function. So even though 0 and 2 both map to 8, we're a function. Where it fails to be a function is when -1 also maps to 3. So the y's could repeat a million times, the x's cannot repeat, and then you have -2 also mapping to 3. So it's not a function because of x equals -1, and it's also probably not continuous because of that fact that it is not a function, so it's not going to be very pretty. So this is a discrete relation.